Let's look at balanced equations and mole ratios and how they help us with stoichiometry. So let's say we're given this equation, and then we're asked some question about, oh, I don't know, let's say, how many moles moles of hydrogen gas can be formed from 3 moles of iron. So let's say that's our question. Notice this equation is not balanced. So the first thing we have to do is balance it. If you look here at the iron oxide, you'll notice that there are 3 atoms of iron. Over here, there's only 1 atom of iron. So let's start by putting a 3 here and then see where we go from there. Now, the next thing we notice is that here we have 4 oxygens, and here we only have 1 oxygen. So we'll put a 4 in front. Notice that as we're balancing this equation, we're only putting numbers in front. We are only changing coefficients. That's it. We are not changing subscripts. You don't do that when you're just balancing an equation. Okay, now let's look and see. We have 3 irons, 3 irons. We have 4 oxygens, and we have 4 oxygens. Here we have 8 hydrogens. Well, we need 8 hydrogens over here, but this hydrogen gas is made up of 2 hydrogen atoms, so in order to have 8 hydrogen atoms, we need to put a 4 here. Okay, so now our question is how many moles of hydrogen gas can be formed from 3 moles of iron? The reason it was so important to balance this equation is that these coefficients tell us something about moles. This tells us that 3 moles of iron react with 4 moles of water to form 1 mole of iron oxide and 4 moles of hydrogen gas. So if we have 3 moles of oxygen, then this 3 moles of iron, that's going to make 4 moles of hydrogen gas. So 4 moles. But let's make it a little harder. Let's say the question is, how many moles of iron are needed to make 1 mole of iron oxide? Okay, so we have 1 mole of iron oxide here because that's a 1 in front. So how many moles of iron do we need? We need 3, so 3 moles. All right, so let's say we have 1 mole of iron now, so we're going to change things. How many moles of water do we need? So how many moles of water are needed to react with 1 mole of iron? Here's where the mole ratio can be really helpful. So you start with the number that you're given. So it's 1 mole of iron. So I'm going to start with 1 mole of iron. Then I'm going to multiply by a mole ratio. So on bottom, I'm going to put moles of iron because I need those to cancel out. On top, I'm going to put moles of what I'm trying to get to. I'm trying to get to moles of water. Now the numbers I put in here are the numbers from my balanced equation. And so moles of iron, if I go to my iron, I have 3. Moles of water, I have 4. So what's my mole ratio? It's 4 over 3. That's my mole ratio. And I did it this way so that my irons would cancel out. So 4 divided by 3 is 1.33. 4 divided by 3. 1.333. 1.33. Notice I'm not really worrying about significant figures here. I didn't put any in here. Let's assume that I've done 3.00. So 1.33 moles of water. Okay, well let's try another one using the mole ratio. Let's say our equation this time is we have 8. Let's not do that one. Let's say we have carbon. I don't like that one either. How about this one? We have carbon disulphide. So carbon disulphide plus 3 oxygen gas. Notice oxygen gas is always O2, just like in the previous example, hydrogen gas was H2. You need to make sure you know your diatomic gases. Those are the ones that always show up with a 2 when they're by themselves. Those are hydrogen, H2, oxygen, O2, nitrogen, N2, and then your halogens, fluorine, F2, chlorine, Cl2, iodine, I2, and bromine, Br2. And that's just when they show up by themselves, as they're going to be diatomic. Okay, so carbon disulfide burns in oxygen to yield carbon dioxide. And that's a capital O for oxygen, carbon dioxide, and sulfur dioxide. Now notice I was really nice and I gave this one to you already balanced. Make that a little neater. So carbon dioxide. So it's already balanced. We have 6 oxygens here. Here we have 2 times 2 gives us 4 oxygens, plus 2 is 6 oxygens. 1 carbon, 2 sulfurs, 2 sulfurs, so it's already balanced. And let's say that I have 1 mole of carbon sulfide reacts with 1 mole of oxygen. And our question is, actually, let's just say 1 mole of carbon disulfide. Just one mole of carbon disulfide. Not worry about how many moles the other thing we're reacting with. We'll get to that later. 1 mole of carbon dioxide, and we want to know how many moles of carbon dioxide and sulfur dioxide are formed. Okay, this one's easy. Okay, we just look at it. 1 mole of carbon sulfide. Look, we already have a 1 on here. So that's 1. So how many moles of carbon dioxide do we make? 1 mole of carbon dioxide. How many moles of sulfur dioxide? We make 2, because our number that we were given, 1 mole of carbon sulfide, already matches up. So that one's pretty easy. But let's try one that's not so easy. Let's see. How many moles of oxygen are required to make 1 mole, actually let's say to make 5 moles, make it harder, to make 5 moles of sulfur dioxide. Okay, so the way we do this one's a little harder. It's harder to see just by looking at the equation. So we're going to start with the number from the problem, 5 moles of sulfur dioxide. So 5 moles of sulfur dioxide. Then we're going to multiply by a mole ratio. Now our mole ratio is going to has to have moles of sulfur dioxide on the bottom, and on top we're trying to get to moles of oxygen. So I'll put moles of oxygen up here. Now to get the numbers in front, this is our mole ratio. To get our numbers in front, we go to our balanced equation. So moles of sulfur dioxide, that'll be 2. Moles of oxygen, that'll be 3. So let's remind ourselves where these numbers came from. The question was, how many moles are required to make a number of moles? So this is moles to moles. When it's moles to moles, you're going to use a mole ratio. Notice there's no grams in here at all. It's just moles to moles. So we start with the number we're given, which is 5 moles. So 5 moles. And then we're going to multiply by the mole ratio. Now what ratio do we use? Whatever substance we have here goes in the denominator. So the substance from the problem in the denominator. The substance we're trying to get in the numerator. Where do these numbers come from? The balanced equation. That's why it's so important for the equation to be balanced. So moles sulfur dioxide, 2. Moles oxygen, 3. So now what we need to do is we have to multiply everything that's on the top and divide everything that's on the bottom. This will become more important when we have longer equations. So on top we have a 5 and a 3. On bottom we have a 2. Multiply the things on top, divide the things on bottom. So 5 times 3 divided by 2 gives us 7.5. And so our answer is 7.5, and 7.5 what's? Well, let's cancel our moles SO2, 7.5 moles of O2. So we're left with moles of O2. Was that what we were trying to get? Yes, because it asked for number of moles of oxygen.